Where should we start?
Let's start at the very beginning.
Time to start with orbital mechanics. Yay! We're going to look at a historical perspective. So first, a couple definitions that you should record in your engineering notebook. An orbit is motion of one body around another. Although it's not typically the case, one object is typically very large in relation to the other. So we're talking like moons and planets, or satellites and planets, things like that. Like I said, that's not always the case. There are two objects that can orbit sort of around each other, which we'll get into later. In this case, the smaller object is said to orbit around the larger, and the larger is typically presumed to be fixed in space. So, a satellite, today we typically think of a satellite as something human-made that orbits the Earth, but as we mentioned when we were talking about space junk and things like that, anything that orbits another body is a satellite. So planets in our solar system are satellites of the sun, the moon is a satellite of the Earth, so these might be good examples to write down for examples of satellites. Planets around the sun, moon around the Earth, those kind of things. All right, looking at where this all started. So it's good to get kind of a background as to where we got into orbital mechanics. But it started in ancient Greece. There was interest, at least in ancient Greece. Aristotle studied the motion of the planets in the night sky. And there was a general understanding at the time that the Earth was fixed in space and everything else orbited around the Earth. That was kind of where people were back in ancient Greece, back in Aristotle's day. Then in the late 1400s to 1500s, Copernicus was the first to theorize that the Earth and other planets revolved around the sun, and it was heretical at the time. People thought that he was crazy, didn't know what he was talking about, but he really studied planets' motion, and that's kind of how he figured this whole piece out. So he assumed the motion at this time to be circular, and took very accurate measurements. And found that his assumption was not strictly accurate, but he was pretty close. Then moving on to the late 1500s was Tycho Brahe, and he was responsible for gathering a lot of information on planetary motions. And that was to the benefit of Kepler, who used a lot of this information and really was one who received most of the credit for it, although he was just the assistant to Brahe, that he proposed, using a lot of those measurements, that the planetary orbits were elliptical, and proposed laws to study orbit motion that we still use. So you're going to learn more about Kepler's laws later on, but really it was measurements taken by Brahe before that. Robert Hooke, and as you may remember from physics, he was responsible for developing Hooke's law, which he named from himself, like all good scientists do. And he liked to debate Newton on facts about orbital mechanics, which takes us to Newton in late 1600s to early 1700s. And he grew interested in mathematics from reading about astronomy. So that was sort of his kind of catalyst in that. Now, from Kepler's work, about 100 years earlier, or shortly around that, he deduced the existence of an inverse square law attractive force, and that is the theory of universal gravitation. So Newton proposed this based on work from people from Kepler, and Kepler's work was based on Brahe, and that was based on Copernicus. So all of these people sort of used each other's work to grow our knowledge on planetary motion. And then he wrote Principia, which was considered the greatest scientific book ever written, which had all of Newton's three laws, which you are probably very familiar with by now. So in conclusion, there was an interest in orbital motion that was back to ancient history, where we thought that the Earth was the center. And the first assertion that it was not was in the mid-16th century. And then all of that sort of led directly to Newton's Principia and the three laws. From the study of orbital motion from the 16th century until Newton focused on how planets orbited the sun, then he proposed that the planets orbit the way they do because of the theory of universal gravitation. And at the moment, Kepler's and Newton's laws still govern what we understand about orbital mechanics. So you are going to learn more again about Kepler's laws coming up.